Hello, and welcome to this training session on the PIEVC protocol. My name is Kirsten McMillan from the Climate Risk Institute. In this session, we're going to talk about what PIEVC is, why it was developed, and how it has been applied. And then we'll go into the steps of PIEVC through a short case study, where we'll also be able to identify some of the outcomes that can come from completing a PIEVC assessment. To start, at the most fundamental level, PIEVC is looking at climate, so some of the acute events like an extreme rainfall event and some of the chronic issues like long-term changes to temperature, and thinking about how that impacts infrastructure elements. So we're really looking through that piece in between that looks at vulnerability of infrastructure elements due to climate and climate change. First, let's start with what PIEVC is. PIEVC stands for the Public Infrastructure Engineering Vulnerability Committee. This committee was formed by Engineers Canada in 2005, and they developed the PIEVC protocol, which is an approach to climate change and infrastructure vulnerability and risk assessments. Since 2005, the protocol has been revised and revamped and applied to over 150 assessments across Canada. This is all done through the PIEVC partnership, which was created in 2020 with the Institute for Catastrophic Loss Reduction, the Climate Risk Institute, and GIZ. Together, the partnership helps to administer and promote the use of PIEVC in Canada and internationally, and runs capacity building and training experiences like this session today. We've also created new resources like the PIEVC High-Level Screening Guide and the PIEVC Portfolio Manual to change how PIEVC can be used in different applications. PIEVC is a step-by-step process that helps to develop a clear picture of an infrastructure system and how the components are vulnerable to climate change. It starts off with setting the scope, context, and criteria for the assessment, and then moves into the data gathering phase, where you'll start to look at historical climate events and the likelihood of these occurring currently and into the future, and then thinking about the infrastructure elements and how vulnerable these may be to these climate changes. This moves into the assessment stage, where you start to estimate the consequences of climate impacts on each element, and this helps to enable the identification of higher risks and how these threats will play out in the system. Altogether, these steps help to inform engineering judgment and think about what components should be prioritized for adaptation. To date, over 150 assessments have been conducted in Canada, Costa Rica, Honduras, Brazil, Vietnam, Lesotho, Georgia, and of course in the Nile Basin region. The assessments range quite a lot depending on the infrastructure type, so we've seen things like coastal infrastructure, transportation and roads, ports, electricity and solar systems, bridges, wastewater, water treatment, and stormwater, different types of buildings and hospitals. But I think that the most important part is that every different infrastructure type and every location follows the same basic procedure, but can really be changed or scaled depending on the type of assessment. The PIEVC protocol is very flexible in the sense that it could be something that takes years to conduct and has many, many different subject matter experts, or can be something that can be done relatively quickly as a screening exercise. So if you want to find more about the different assessments that have been conducted, you can check out the PIEVC website, where you'll be able to see all of the different assessments that have been released publicly, which helps to learn from the experience of other projects that have been done. In today's session, we want to give you some of the hands-on skills it takes to complete a PIEVC assessment. So we're going to walk through each step for a real-world example for a vulnerability assessment that was conducted on a highway system in Canada. The first step is to set the scope, context, and criteria. So for this example, they knew that they wanted to look at the highway system and see how vulnerable it was to climate change, but they had quite a lot of highway systems to look at. So instead, they decided to scope it into smaller pieces, and this shows one segment that was approximately 45 kilometers, and use this for the evaluation. This helped the assessment team dive in a little bit deeper to the individual components and be able to look at one climate system instead of looking at a range across the entire length of the system. They also knew that this highway was intended to be driven upon up to the 2050s. So when they looked at the effects of climate change, they wanted to make sure that they were assessing the baseline and what it looks like now, and then what it could look like in the future. So all of these help to set the stage for the scope, and they also help to bring together who's going to be a part of the assessment team in this stage. So different subject matter experts, and start to think about what type of data is available and how you might use it. Moving into the second stage, we're thinking about gathering data. So starting off with elements. This is something where you want to pull together things like design reports or drawings, and then really have some of those interviews and conversations with people who know the system very well. So for example, engineers that are involved in the design process, or operations and maintenance staff who are very intimately familiar with the system and perhaps how it has already responded to climate events. From here, you can develop a preliminary list of the components and then walk this through with the team again. So for this example, they came up with a number of different components and then divided these into three main categories: drainage, road, and highway safety. At the same time, we have the climate team who's going through to look at the current climate conditions and vulnerability and how these are expected to change over time. In this assessment, they had a group of climate scientists that were working on it, as it was something that had never been done in the region before. The climate scientists had to work with the engineers and other subject matter experts to come up with what climate events are of greatest concern. So for example, they may know that high temperature is an issue for the system, but when you actually get through a conversation, you can turn this into something like a threshold. So we know that if temperature is over 30 degrees, you might have more substantial impacts to things like the roadway systems compared to 25 degrees. So this is always a conversation that comes between climate expertise and engineering expertise to make sure that you're hitting on the numbers that are most relevant to the system. And this often requires professional judgment and a lot of conversations between people to make sure that you're looking at the right things. So to start, when they were thinking about what climate change was actually looking like on this system, they found that there was changing with warming, so increasing hot extremes and decreasing periods of hard frost. There was a reduction in the range of temperatures. There was an increase in periods of heavy precipitation, and an increase in frequency and magnitude of atmospheric river events. So this is a specific type of storm that occurs in this region of Canada due to the high mountains and the coastline. They also saw a decrease in snow frequency and a decrease in the intensity of snowstorms. Next up, we move into the assessment phase. So here you can see a list of the infrastructure elements. So we have the drainage, the road, and highway safety. And then we have some of the climate parameters that were selected. So we see things like temperature and rain. You then want to compare each element with the climate event and see if there's any kind of interaction. So for example, when we're looking at culverts that are greater than 3 meters, we can see how there'd be impacts from high and low temperature, and of course, a lot of impacts associated with rain. So as a group, you can work through each of these and see where the interactions exist. From here, you move into the risk assessment process, where we have the likelihood score, which is developed often by the climate team. And then you have whether or not there's an interaction, like we mentioned on the previous slide, and begin to think about consequences. So this moves us into the risk scoring process. So we have our consequence score, which can be something ranging from 1 to 5, where there's really no effect or an insignificant effect, all the way to something that could be catastrophic. So we would have extreme financial losses, impacts to the environment, impacts to public health and safety. So really thinking about that most extreme consequence. We then are thinking about the likelihood. So things that are highly improbable, all the way to something that could happen frequently. So when we're looking at our risk score, it's the combination of these two. So if we had a likelihood score of 2 and a consequence score of 5, the risk score would be 10. So you could also think about these things that are these extreme events, and if they were occurring much more frequently, this would be something that would be an extreme risk to the system and that you would want to identify as soon as possible. Of course, it's really important to document the outcomes of the PIEVC process. So this is when we go into reporting. So in this example, they identified that extreme rainfall and these atmospheric river events were of greatest concern. But they also recognized that they couldn't figure everything out through this process. So for example, they knew that fog could be a big issue on the highway system, but the science wasn't quite there to be able to assess if fog would change due to climate change. There's also things like the design reservoir capacity and how changes to hydrology would impact the system, and things like high winds. So at this point, it may be recommended to move some of these risks into an engineering analysis where you can have a much more detailed look into these components. You could also just make the recommendation that there is some uncertainty here and it could be investigated more into the future. Finally, for the reporting, they recommended that there were some upgrades made as part of the regular design and maintenance activity. So this report was released in March 2010, and the findings of the reporting were that the system is generally resilient to climate change. However, they identified that atmospheric river events present a significant risk to the infrastructure, especially for drainage management issues. They found that these types of events could have extreme issues with safety and serviceability. They also were worried that these could increase in the future in both frequency and magnitude, and this was more concerning because there was already vulnerability in the system. And unfortunately, what they found in November 2021, very recently, is that one of these atmospheric river events did occur, and you can see here that this bridge in the highway segment that was assessed was completely washed out. So this real-world example, in this case, the highway was closed for more than a month, and since then the government has been investing quite a lot in reconstruction so that this segment is more resilient to climate change. But I think it's a really important example because the PIEVC protocol was able to identify some of these vulnerabilities, and although there are recommendations for adaptation, they might not have been able to happen at the speed or with the level of investment required to be able to respond to this event in November 2021. However, it did make the case for making infrastructure more resilient to climate change in the future. In summary, in this training session, you learned what PIEVC is, which is a step-by-step approach to understanding how infrastructure systems are vulnerable to climate change. We then talked about the main steps of PIEVC, which we walked through with an applied example for a highway system in Canada. Thank you for your attention and learning with us today, and we hope to see you in the future.